This is going to be a short lesson on motors and encoders, especially when used for our robotic application. So let's take a look. If we have a robot here, and let's say this is the wheel out here, and this is the motor and gearbox set up in there. By the way, this is an explosion or a closer up of what is in there. We'll want to go forward, and in fact, one of these wheels is going to have to turn clockwise, and one is going to turn counterclockwise. That's the subject of another lesson. But if we take a look at, we have a wheel, and the wheel is primarily driven by a motor. And when the motor turns, sometimes it just doesn't have enough torque or enough mechanical energy to be able to turn and move the entire robotic vehicle. So often what designers will do is they'll put in place a gearbox, and a gearbox will allow the many turns of the motor to be reduced down to fewer turns, but it will amplify the torque or the power available to move this vehicle. So, for example, we might have a situation where we have a 50-to-1 ratio of the motor wheel, or I should say 50 for the motor and 1 for the wheel. And if we have that in place, then of course you'll need to have it on both sides. This gearbox will be able to allow you to translate a lot of turns of the motor for 1 turn of the wheel. But very often we want to also ensure that we can measure how many times that motor turns. So often what we do is we add another device here, and this is called the encoder. The encoder sometimes looks very much like this. This would be an optical encoder. Is a type of robotic sensor that will tell us how many times that motor turns. Often what you have is some sort of a reflective, or I should say a light source that is going to rely on reflection back off of the surface of this disc, and this light that then reflects off this white portion of the disc will generate a pulse. And in fact, perhaps you might find that when it enters this white region, you'll get a rising edge of a pulse. And when it leaves the white region, you'll get this falling edge of the pulse. And if it turns all the way around 4 times, then you're going to get 4 of these pulses. And one way we can determine how many times that wheel actually turned is by taking a look at, oh, okay, so if we have measured 4 pulses, that's going to be equal to 1 motor turn. So if you look at, well, if you have 4 pulses and 50 motor turns, then we're going to see that 200 pulses is going to be equal to 1 wheel turn. So later we're going to be looking at some concepts with respect to how do you program this motor, how do you measure this encoder, and all of that is going to be the subject of a future lesson. Thank you.